We'll cast your mind back to February last year. And you may remember the excitement when NASA successfully landed its Perseverance rover on Mars. This crater that you see here was a lake 3.2 billion years ago. So we are looking at the same environment in the same time period. NASA's Mars rover Perseverance has sent us the most incredible footage of Mars. With its advanced cameras and cutting-edge technology, the rover has taken high-definition 4K images that transport us to the surface of Mars like never before. As it explores the planet's ancient terrain and uncovers new insights, Perseverance offers a stunning visual journey into an alien world, continuing the legacy of its predecessor, the Curiosity rover, which gave us visuals of Mars in 4K. Both of these are pushing the boundaries of space exploration. So why is NASA spending billions for a bunch of photos? Well, they are more than visuals. To fully understand the importance of these accomplishments, we need to look at the whole thing from the very beginning. Rovers have been instrumental in expanding our understanding of the Red Planet. Over the years, NASA has sent several groundbreaking rovers to Mars, each more advanced than the last, with missions that span over 2 decades. The first major rover, Spirit, was launched in 2003 alongside Opportunity, both tasked with searching for signs of past water. Their discoveries helped solidify the idea that Mars once harbored conditions suitable for life. In 2012, Curiosity revolutionized our understanding by landing in Gale Crater and providing high-resolution images and critical data about the planet's climate, geology, and potential habitability. Then in 2021, Perseverance arrived. Equipped with state-of-the-art technology to search for biosignatures and collect samples for future return missions. Through their lenses, these rovers have offered humanity an unprecedented glimpse of Mars, sending back stunning imagery and helping scientists visualize its landscapes. Let's see how the greatest minds on our planet made all of this possible. As part of the Mars Science Laboratory mission, NASA's Curiosity rover was launched from Cape Canaveral on November 26, 2011, marking the beginning of a bold journey that would take it 560 million kilometers, 350 million miles across space to the surface of Mars. On August 6, 2012, after a thrilling entry, descent, and landing sequence, the rover touched down safely on Aeolis Palus, a flat region in Gale Crater near the base of the towering Mount Sharp, which stands at 5.5 kilometers high. From its landing site, Curiosity began its exploration with a singular focus, to investigate the planet's climate, geology, and potential for past microbial life. Gale Crater, chosen for its diverse geological features, was considered an ideal location due to evidence suggesting that water once flowed there. The rover's exploration aims to answer a key question: could Mars have supported life? And more importantly, can it do so in the future? By examining the Martian soil and atmosphere, Curiosity aimed to detect key elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. It also sought to identify features that might indicate biological processes such as biosignatures or biomolecules. Curiosity was also tasked with analyzing the composition of the Martian surface, including studying the chemical, isotopic, and mineralogical makeup of rocks and soils, as well as interpreting the geological processes that have shaped Mars' surface. One of the rover's key tools, the ChemCam, chemistry camera, used a laser to vaporize small portions of rocks and analyze the resulting plasma to identify chemical compositions, which helped map the history of water and volcanic activity on Mars. The rover also measured the present state of the Martian atmosphere, focusing on the distribution and cycling of water and carbon dioxide. These observations are pivotal for understanding the planet's climate over billions of years, providing insights into its habitability and its shift from a potentially warm and wet world to the dry, cold planet we see today. The data gathered could also aid in future efforts to terraform Mars or prepare for human exploration. Curiosity also carried instruments to study surface radiation by measuring galactic cosmic rays, solar proton events, and secondary neutrons. The rover provided crucial data for understanding the hazards posed by radiation on the Martian surface. A groundbreaking discovery unfolded in 2013 when the rover found evidence of an ancient stream, suggesting that liquid water once flowed through the Gale crater region. The presence of clay minerals, which form in the presence of water, further bolstered the idea that Mars once had an environment capable of supporting life. Curiosity's analysis of the Martian atmosphere, specifically its methane levels, has provided intriguing clues about possible biological or geological processes occurring below the surface. The rover has also reshaped our ability to visualize Mars in ways never before possible. Using its Mastcam and other imaging systems, it has sent back some of the most iconic images of Mars. The high-resolution images have provided stunning views of the red rocky terrain, its ancient weathered landscape, and even its towering mountains and deep valleys. Perseverance will shape the future of space exploration for decades to come. The rover's first test drive on Mars, conducted on March 4, 2021, produced the first wheel tracks on the Martian surface. In addition to its exploration, Perseverance is also collecting samples to be returned to Earth as part of the Mars Sample Return mission. The rover has cached several Martian samples, including regolith, rock, and atmospheric samples for future analysis. The rover's ongoing mission has also led to some exciting discoveries, including the identification of leopard spots on a Martian rock that may provide clues about the planet's potential for hosting life billions of years ago. The Perseverance mission has also inspired people around the world. NASA's Send Your Name to Mars campaign garnered over 10 million names that were etched onto chips on the rover, symbolizing humanity's shared interest in space exploration. The mission also paid tribute to healthcare workers during the COVID-19 pandemic with a symbolic plate attached to the rover. Additionally, the rover's parachute featured a hidden coded message, "Dare Mighty Things," a phrase that has become synonymous with NASA's ambitious goals. Speaking of ambitious goals, we also have fresh visuals from the Red Planet. The Octavia E. Butler landing photo taken in February 2021 captures the moment Perseverance touched down on Mars. The smoke plume from the descent stage is visible, marking the rover's safe arrival. Another image from the rear right hazard avoidance camera provides a clear perspective of the terrain, helping the rover avoid obstacles. A captivating image taken on Sol 213 shows the parachute and back shell lying on a ridge about 2 kilometers north of where Perseverance now rests. The first color photo taken by Perseverance offers a vibrant image of Mars' surface, showing its reddish terrain, rocks, and dust. A panoramic shot taken on Sol 14 provides a sweeping view after Perseverance's first long drive, revealing the vast, rugged Martian landscape. Other images include an aerial shot of the rover from the Mars Reconnaissance Orbiter and reciprocal photos of Perseverance and Ingenuity capturing each other. One of the most significant achievements in aerospace history is the first controlled flight on another planet, which occurred when Ingenuity took flight at the Wright Brothers Field in April 2021. Another remarkable image, the Van Zyl Overlook, provides a stunning panoramic view of Mars' rolling terrain. Ingenuity has also provided video and audio of its fourth flight on April 30, 2021.